Hello everyone, welcome to the solution of LeetCode problem 141 named linked list cycle. In this problem, we are given a linked list and we have to determine whether this linked list contains a cycle or not. Let's consider this first example. Here we can see that the linked list element -4 and 2 are connected and 2, 0, -4 contains a cycle. Similarly, in the example 2, 1 and 2 contains a cycle. But in the example 3, the only element 1 does not contains any cycle, so we have to return false. But in the previous two example, we have to return true. I hope you understood the problem statement. And here, we have to return true if the linked list contains a cycle, and otherwise we have to return false. Now, there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. That means, suppose this node 2, we can reach this element 2 by right shifting one pointer 1 time, 2 time, and 3 time. So internally, position is used to denote the index of the node that tail's next pointer is connected to. Now note that this is not passed as the parameter. Okay, I hope you understood the problem statement. Now let's move on to the code. Here, in the coding part or in the algorithmic section, let's take this example. Here, this is the linked list that contains a cycle, and the cycle is this 1, 2, 3, 4, 2, 1, and 1. So, how can we determine whether a linked list contains a cycle or not? Now, before jumping into the solution, let's understand the hypothesis. The hypothesis is, if we take two pointers, suppose one pointer is slow, another pointer is fast, and the speed of slow pointer is 1 unit, right? And speed of fast pointer is, let's say it is 2 unit, right? Now, the basic hypothesis is, if in any of the cycle, we move two of the pointer, and if their speed is not equal, then after some of the iteration, at any point of time, these two pointers will meet each other. Suppose, let's take one pointer slow, another pointer fast. Both of them are initially in the first element. Now, slow is shifted 1 unit and first is shifted 2 unit. 1 unit here, 1 unit here. Okay. Now again, slow is shifted 1 unit, first is shifted 2 unit. Again, slow is shifted 1 unit, first is shifted 2 unit. So far so good. That means here we can see that the slow pointer is pointing to element 1 and the first pointer is pointing to element 4. So here the speed of the slow pointer is 1 unit and speed of the first pointer is 2 unit. And according to the hypothesis, in any cycle, if the speed of the both pointer is not equal, that means these two pointers will meet after some of the iteration. And if the speed of the both pointer is equal, then it is not possible for the pointer to meet once again. Now, S will be shifted 1 unit here and F will be shifted 2 unit here. Now, S will be shifted 1 unit here and the F will be shifted 1 unit here. Now, S will be shifted 1 unit here and F will be shifted 1 unit and 1 unit, which is 2 unit here. So, F will be again into this position. So here we can see that this element 4, we have two pointers, which is slow and fast. So this is the convention. That means the slow pointer and the first pointer meet each other. So here we can say that this linked list contains a cycle. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named hasCycle, which has a list node head as a parameter. Now, if the head is null, we have to return false. That means it is not containing any cycle. Now, we are taking two pointers, slow and first. Both of them are pointing to the head element initially. Now, here, if the first of next and first of next is available, we have to shift the slow pointer 1 unit and first pointer by 2 unit. And if inside this cyclic loop, the slow is equal to first, we have to return true. That means we have found a cycle. Otherwise, we have to simply return false. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.